Okay, طلبة. The last subject for the introduction part for the atom and bonds is the Lewis acid and bases. The Lewis definition of acid and base is more general than the Bronsted-Lowry definition. Why is more general? We will know. He said here, a Lewis acid is an electron pair acceptor. Look, we talk here about the electron pair, not Bronsted. Bronsted always talk about the proton donor, proton acceptor, but here the Lewis acid, here talk about the electron pair acceptor. And the Lewis base is an electron pair donor. Lewis bases are structurally the same of the Bronsted-Lowry bases. Okay, the structure, okay, for the Lewis and the Bronsted base slightly the same. Okay, why? Because both have an available electron pair. Both of them have available electron pair. The electron pair maybe it will be a lone pair, يعني electron non-bonded, or maybe two electron for the pi bond, double bond, triple bond. Okay, and the Bronsted-Lowry base always donate this electron pair to a proton. The Bronsted, if you remember, give the n-shape of electron for the proton. The n-shape of electron attack the proton. But the Lewis base donate this electron pair to anything. Look here, to anything that is electron deficient. To anything that is electron deficient. For this reason, we said here anything that's electron deficient. For this reason, it will be more general. Okay, and look for this example. Example for Lewis base. All this is bases. Maybe it is negative charge, n-shape of electron, or maybe it will be equal. There is no negative or positive charge, but there is n-shape of electron, or maybe it will be double bond or triple bond. Okay, and he said here a Lewis acid must be able to accept an electron pair. That meaning Lewis acid accept an electron pair, but there are many ways for this to occur. Okay, how to accept? There is many ways, and all Bronsted-Lowry acid. Look, all Bronsted-Lowry acid are also Lewis acid. He don't say all the Lewis acid is Bronsted-Lowry acid. No, it is wrong. But all Bronsted-Lowry acid are Lewis acid. But the reverse is not necessary. True. Okay. Now, if you don't understand this sentence, I will explain for you for the next slide. And any species that is electron deficient and capable to accepting an electron pair is also a Lewis acid. Okay, what meaning here? All Bronsted-Lowry acid are also Lewis acid, but the reverse is not true. Okay, we will go here. Look to the acid. I will make for you this just for understanding. This is the acid and this is the base. Okay, now look to the Bronsted acid, proton donor. Okay, look to the Lewis acid, n-shape of electron acceptor. But here, look to the Bronsted acid. Look, the n-shape of electron, it will be accepting from the base. Okay, that meaning also the Bronsted acid is electron pair acceptor like the Lewis. But the reverse is not true. Why? Because there is no proton. For Lewis, there is no proton. Okay, for Bronsted, yes, there is a proton. For this reason, all Bronsted acid is Lewis acid, yes. But the reverse is not true. The reverse meaning not all the Lewis acid is a Bronsted. Okay, that meaning is not true. And the base is, look to the base. We say the Bronsted base and Lewis base structurally is the same. Why the same? Because both of them, look, has n-shape of electron. This n-shape of electron, also this n-shape of electron. But the Bronsted give the n-shape of electron just for a proton. Okay, but here the Lewis, no. The n-shape of electron for anything electron deficient. Okay, for anything electron deficient. And the common example for Lewis acid which are not bromistid lauric acid include BF3 and AlCl3. Okay, this compound contain elements in the group A3 in the periodic table that can accept an electron pair because they don't have full valence shell of electron. That meaning the outer shell for these elements, for the boron and aluminum, is not with 8 electron. Okay, maybe 7, maybe 6. Okay, that meaning the outer shell, the valence shell electrons is not filled. Okay, and look to this example, H2O and CH3OH. These compounds are both bromistid lauric acid and Lewis acid. But here, this and this, they are just Lewis acid. Okay, we cannot say for this is a bromistid acid. Why? Because there is no proton. Okay, this compound unshaped of electron acceptor. For this reason, it will be Lewis acid. And in Lewis acid base reaction, a Lewis base donate an electron pair to Lewis acid. Most of the reaction in organic chemistry involving movement of the electron pair, that meaning the electron pair, it will be moved from one to another. Okay, can be classified as Lewis acid base reaction. Lewis acid base reaction illustrates a general pattern of reactivity in the organic chemistry. Is the electron rich species react with the electron poor species. Okay, poor يعني فقير يعني electron deficient. Okay, ناقص إلكترونيا. That meaning the electron rich react with the electron poor. Okay, and there is something important for the Lewis acid reaction. In the Lewis acid reaction, if you look to this reaction, this unshaped of electron attack the boron because the boron is electron deficient. Okay, and there is a new bond. But if you look, there is no bond, it will be broken. Okay, that meaning in the simplest Lewis acid base reaction, one bond is formed, this bond is formed, and there is no bond, it will be broken. But in the bromistid lauric acid base reaction, there is one bond formed and the other bond, it will be broken. If you go back to the reaction for the bromistid acid and base. Okay, and here no, there is just a new bond that will be formed. Okay, this the different. And here the H2O donate an electron pair to the BF3 to form a new bond. Okay, and again Lewis acid is also called the electrophile. Okay, electrophile يعني محب للإلكترونات. Okay, he want electron. Okay, and look this is electrophile. Why? Because can be take this the unshaped of electron. Okay, can be take the unshaped of electron. And for the Lewis bases, it will be nucleophile. Why the nucleophile? Because they attack the nucleophile here. Okay, the nucleo. This attack this nucleo. Okay, this for this reason it will be the base. It will be nucleophile. And in this Lewis acid base reaction, BF3 is the electrophile. This the electrophile, and this the nucleophile. And here two other examples are drawn here. In each reaction, the electron pair is not removed from the Lewis base. The electron pair, it will be not removed from the Lewis base. It will be make a new bond. Okay. Look to this new bond and also this a new bond. Okay. And this homework for you. Try to resolve this homework, please. And also you have another homework here. And طلبة again, I will give you this reference. If you have it, you can see this reference. This reference is so important. If you don't understand some subject, you can try further reading by go to look out about this reference. It will be helpful for you. And also try again to resolve all the homework on the notebook, and see you later inshallah.